They say the Mesozoic was a time of primeval peace, a world shrouded in humid tranquility, a green Eden ruled by gentle giants. They are wrong, terribly, dangerously wrong. The Mesozoic was a battlefield, a 60-million-year-long, high-stakes game of survival, where the rules were written in the serrations of a blade-like tooth and enforced by the crushing power of a 6-ton bite. We are watching now, in the shadow of a petrified redwood, as a young Pachycephalosaurus, its skull reinforced like a granite battering ram, has its flank torn open by a creature that defies simple description. Not because it is large, though it is a mountain of sinew and muscle, but because of its eyes. They are the eyes of a calculating intellect, eyes that see not just flesh, but weakness, opportunity, and the cold, unyielding mechanics of the kill. This is the world of the apex predator, a realm where evolution didn't merely create large creatures, it perfected murder. The air is thick with the scent of pine and decay, the ground trembling under unseen footfalls. This is not the Jurassic Park we imagined. This is the Cretaceous reality, a world that has undergone a ruthless evolutionary crucible. The initial, sprawling, relatively unspecialized forms of the Triassic gave way to a relentless genetic arms race, culminating in predators honed to a razor's edge. The Mesozoic era, spanning over 180 million years, was the ultimate workshop of biological engineering. It was here, in the swamps, forests, and volcanic plains, that natural selection performed its most exquisite and terrifying work. We often focus on the size of these beasts, the sheer, staggering scale of an Argentinosaurus or a Tyrannosaurus, but the true story lies in the specialization. Size was merely a byproduct of a world of giants. Adaptation was the key to dominance. Consider the stakes. The world was a dynamic tapestry of shifting continents, fluctuating sea levels, and changing flora. To survive a decade, let alone a geological epoch, required a level of biomechanical perfection we struggle to comprehend. Every tooth, every muscle fiber, every air sac in the respiratory system was optimized for the singular goal of perpetuating life, often at the immediate expense of another. The giant sauropods, the armored stegosaurs, the feathered dromaeosaurs, they all represented a distinct and deadly solution to the problem of existence. This was an unforgiving environment where a split-second hesitation meant the difference between a successful kill and a fatal counterattack. A broken limb meant a slow, agonizing death. Evolution, in this context, wasn't a gentle nudging toward improvement. It was a brutal, Darwinian blacksmith, hammering life into lethal instruments. We see the teeth designed to shear flesh like industrial steel. The claws evolved to hook and disembowel, the brains calculating geometry in the heat of a chase. Our journey is a descent into this savagery, a quest to understand the mind behind the muscle, the strategy behind the slaughter. We start with the titans who stood tall, not just because they were huge, but because they had mastered the physics of their environment. The giants who touched the sky and the hunters who dared to bring them crashing down. To understand the predator, we must first appreciate the scale of its challenge. Travel with us back to the late Jurassic period, into the conifer forests of ancient North America. Here, the landscape is utterly dominated by a creature whose very existence seems to defy the laws of gravity and biology. Behold the Brachiosaurus, the arm lizard. It is not a lumbering beast. It is a living crane, a monument of biological engineering that redefined the term colossal. Imagine an animal weighing close to 60 tons, standing over 40 feet high, taller than a 4-story building. Its forelimbs are famously longer than its hind limbs, creating a sloping, giraffe-like posture that was a direct, elegant solution to an enormous ecological problem. The problem was competition. The Jurassic forests were rich, but every creature, from the smallest herbivore to the largest sauropod, was vying for the same low-lying fern and cycad. The Brachiosaurus's evolutionary answer was simple and stunning: transcend the terrestrial struggle. Its massive neck, built of specialized, lightweight but strong vertebrae, allowed it to access a food supply untouched by any other creature, the high canopy of the tallest trees. It was the ultimate vertical feeder, a biological tower designed for exclusive foraging rights. But the physics of this design are staggering. To stand this tall, to pump blood all the way from its colossal, 4-chambered heart to its massive head required blood pressure that would kill a human instantly. The very structure of its arteries and veins had to be a marvel of strength and resilience. It was a living circulatory puzzle solved by millions of years of selection. In the face of such scale, the Brachiosaurus found a kind of relative peace. A juvenile might fall victim to an opportunistic hunter, but a fully grown adult, often traveling in a protective herd, was largely immune. Who would dare challenge a 60-ton fortress? Its size was its primary, impenetrable defense. It lived its life in slow motion, a serene, swaying tower, gazing down on the furious, fast-paced world of its predators. Its life was a testament to the power of pure, unadulterated scale, a constant, rhythmic consumption that fueled a gentle giant's dominance. The colossal presence of the Brachiosaurus did not mean an absence of danger. It simply raised the bar for its predators. We now rewind our focus to the ground level of the Jurassic, to the undisputed predator alpha who faced these titans head-on, the Allosaurus. Long before the T-Rex became a biological legend, the Allosaurus, the different lizard, reigned supreme across the Morrison Formation of North America. It was the definitive predator of the late Jurassic, a creature of speed, agility, and a specialized, shocking method of attack. Look at its skull. Unlike the later bone crushers, the Allosaurus did not possess the immense bite force of its Cretaceous successors. Its jaws were built for a different, more surgical kind of brutality. Its skull was relatively light, its teeth deeply serrated and slightly curved, perfect for slicing. This predator's strategy was not about crunching bone, it was about precision hemorrhaging. The Allosaurus employed its entire head like a massive serrated hatchet. Paleontologists believe it would lunge at its colossal prey, often using an ambush, and smash its upper jaw down, driving its razor-sharp teeth deep into the hide of a sauropod or stegosaur. This was not a chewing motion. It was a rapid, devastating slash-and-retreat tactic designed to inflict massive, rapid blood loss, a death of 1,000 cuts, delivered with the terrifying efficiency of one. Its body was built for this hit-and-run strategy, powerful, yet streamlined legs capable of bursts of high speed, and a counterbalancing tail that allowed for tight, rapid turns. It was the ultimate ambush predator, relying on surprise and the devastating trauma of its initial blow. Furthermore, the fossil record suggests a degree of tolerance among Allosaurus individuals. While perhaps not organized pack hunters like wolves, they likely gathered around large kills or collaborated loosely to bring down a weakened Brachiosaurus. The sheer energy required to slay a sauropod mandated a sharing of the spoils. This ability to operate socially, coupled with its lethal slicing technique, cemented the Allosaurus's status as the king, the undisputed Jurassic executioner. It mastered the art of maximizing trauma while minimizing risk, a critical lesson in the unforgiving economics of the hunt. Now our timeline leaps forward into the mid-Cretaceous, and our journey takes a sharp turn, abandoning the arid, forested uplands for the vast, humid river systems of North Africa. Here, evolution delivered a curveball, a predator that looked at the land wars and simply decided to walk away. Enter Spinosaurus aegyptiacus, the spine lizard. This creature didn't just break the rules of terrestrial dominance, it rewrote them entirely, becoming the first and largest known semi-aquatic dinosaur. A truly monumental beast, possibly exceeding the T-Rex in length, it was an enigma wrapped in the scorching heat of an ancient desert. Its appearance is a story of radical adaptation. Most prominent is the enormous, distinctive sail on its back, a structure of bone spines reaching over 6 feet high. Was it for display, for thermal regulation in the extreme heat, likely both, a flamboyant declaration of its apex status in its unique environment? But the real secret to its specialization lies in its face and body. Its skull was elongated and narrow, like a modern gharial or crocodile. Its teeth were conical and straight, designed not for crushing bone or slicing flesh, but for piercing and gripping slippery, massive prey, the giant fish, sharks, and coelacanths that dominated the Cretaceous rivers. Its jaws were a perfect biological fishing trap, equipped with pressure sensors at the tip, allowing it to detect the smallest movements of prey in the murky water. Furthermore, the anatomy of its skeleton revealed its true calling. Dense bones, similar to those found in penguins and sea cows, served as ballast, allowing it to submerge and control its buoyancy. Its hind legs, while powerful, were relatively short, and recent studies suggest its tail was paddle-like and flexible, the ultimate organ for propulsion in water.
Few outsitters have seen the elder ones and lived.
The Spinosaurus had conquered a niche no other giant had successfully held. While T-Rex and other large carnivores fought for carcasses and territory on land, the Spinosaurus silently patrolled its river kingdom. It demonstrated that dominance is not universal, it is ecological. It was a water dragon, a magnificent monster that found its power by stepping off the land and into the liquid domain, proving that specialization for an environment can be the ultimate path to survival. From the heat of the African rivers, we travel eastward to the arid, ancient landscapes of Mongolia, a place where the rules of predation were not just bent, but seemingly shattered by a creature so bizarre, its initial discovery baffled the scientific world. The year is 1948. A Soviet Mongolian expedition uncovers massive, sickle-shaped claws, nearly a meter long, leading researchers to assume they had found the remains of a colossal, unknown dromaeosaur, an unimaginable superpredator. This was the birth of Therizinosaurus cheloniformis, the scythe lizard. Imagine this creature, a giant bipedal dinosaur over 30 feet long, covered in a shaggy coat of primitive feathers, possessing a small head on a long, slender neck, and a posture often described as resembling a giant, insulated sloth. And at the end of its powerful forelimbs, 3 enormous, terrifyingly sharp claws, the longest claws of any animal in the history of the Earth, looking like 3 massive, curved guadañas. This is where the enigma lies. The Therizinosaurus was not a predator. It was a massive, gentle herbivore. Its teeth were small, leaf-shaped, and designed for grinding, not ripping. The creature was an anomaly, a giant pacifist armed with weapons of mass destruction. So how did it use these intimidating armaments? The answer speaks volumes about the diverse strategies of survival. The primary function of those meter-long scythes was utilitarian. They were perfect tools for feeding, cooking, stripping, and pulling down high branches and thick vegetation to bring leaves within reach of its beak-like mouth. They were biological grappling hooks, designed to harvest the toughest parts of the forest. They also served a crucial role in defense. Imagine a smaller predator, perhaps a pack of Tarbosaurus, the Asian cousin of T-Rex, daring to attack this giant. The Therizinosaurus would become an instant fortress, swinging those immense claws in devastating arcs. A predator wouldn't need to be killed to be deterred. A single, deep, non-fatal wound from that claw would be enough to cause permanent injury and almost certainly a slow death by infection. The threat alone was the defense. The Therizinosaurus is the ultimate contradiction, a giant of contradiction and specialized defense, demonstrating that in the ancient world, the most terrifying weapons were not always wielded for the hunt, but sometimes for the simple, quiet need to eat and survive. The gentle giant's secret was recognizing that an impenetrable defense is just as effective as a powerful offense. Our attention turns now to the most intelligent hunters of the Mesozoic, a lineage that perfected the concept of a cold, calculating, surgical kill, the Dromaeosauridae, the family of the running lizards. In popular culture, The velociraptor is often portrayed as a man-sized, scaly terror. The reality, unearthed in the fossil beds of Mongolia, reveals a truth far more fascinating and frightening. The real Velociraptor mongoliensis was a relatively small predator, closer to the size of a large turkey or coyote, entirely covered in feathers, built for lightning-fast speed and agility. Its danger was not derived from scale, but from intellect and specialization. The Velociraptor had one iconic weapon, the devastating, retractable sickle claw on its second toe. This claw was not primarily a stabbing weapon, but a hook, a grappling tool designed to latch onto prey, providing a point of leverage, while the raptor used its powerful legs and jaws to disembowel or incapacitate its target. Its power was amplified exponentially by its pack strategy. Fossil evidence, like the famous fighting dinosaurs specimen, hints at coordinated attacks, a sophisticated social dynamic far beyond the typical reptile. They were the precision specialists, the evolutionary snipers of their time. But evolution rarely rests. The sheer brutality of the Mesozoic demanded variety, and the raptor blueprint was soon scaled up to terrifying proportions. Meet the Utahraptor ostromacea. If the Velociraptor was the surgeon, the Utahraptor was the armored tank. Weighing over 1,500 pounds and reaching the size of a modern polar bear, the Utahraptor combined the calculating intelligence and deadly sickle claw of its smaller cousin with a truly devastating brute force physique. Its claws were proportionally even larger, essentially 3-foot-long hooks capable of anchoring onto the toughest hides. The Utahraptor hunted the largest prey of its ecosystem, likely utilizing its immense weight and the coordination of a pack to drive an iguanodon or other large herbivore to the ground. It was a perfect blend of high intelligence and raw physical power, the ultimate expression of the dromaeosaur lineage. This raptor demonstrated the lethal versatility of this evolutionary path. Whether small and precise or large and devastating, the combination of a high-functioning brain and a specialized hunting weapon made this family the most terrifying force multipliers of the Cretaceous. We arrive now at the conclusion of the Cretaceous and to the figure who stands as the undisputed champion of the dinosaurian world, the most famous and perhaps most misunderstood predator to ever walk the earth. This is not a story of the largest or even the fastest, but the creature that achieved the ultimate state of biomechanical perfection. For decades, the T-Rex was dismissed by some as a slow, lumbering scavenger, too cumbersome to truly hunt. Scientific inquiry has demolished this myth, revealing a hunter of almost unbelievable refinement. The T-Rex was the ultimate result of millions of years of evolutionary pressure on the super predator niche. Its senses were legendary. Forget the movie trope of being sight-dependent. The T-Rex possessed enormous olfactory bulbs, suggesting an extraordinary sense of smell, capable of detecting death or blood from miles away. More crucially, its eyes were positioned facing forward, granting it exceptional binocular vision, a key trait for judging depth, distance, and the speed of a fleeing prey. It was not a slow laggard. It was a calculating hunter with a sensory package far superior to its predecessors. The T-Rex's skull was not a slicing implement like the Allosaurus's hatchet, nor a gripping tool like the Spinosaurus's snout. It was a massive, reinforced, battering ram and bone pulverizer. Its fused, massive skull bones allowed it to generate the greatest bite force of any terrestrial animal in history, estimated at over 12,800 pounds per square inch, enough force to crush a car. Its teeth were thick, conical, and designed not merely to shear flesh, but to literally shatter bone, allowing it to extract every ounce of nutrients, including the marrow. This was a decisive, one-shot weapon that ended confrontations instantly. The small, vestigial arms, often a source of amusement, are themselves a testament to specialization. Evolution often sacrifices one trait to empower another. The T-Rex focused all its biomechanical energy and mass into its colossal head and neck muscles, making its forelimbs a secondary, minor feature. The T-Rex was a living engine of destruction, a biological masterpiece that could hunt, scavenge, and dominate with an unprecedented combination of sight, smell, and bone-crushing power. It was the ultimate monarch of Laramidia, a final, terrifying statement on the perfection of predation. The reign of the apex predators, the towering giants, the specialized masters of combat, it was all extinguished not by a superior biological rival, but by an indifferent cosmos. A cataclysmic event, the impact of a massive asteroid near the Yucatan Peninsula, plunging the world into darkness, fire, and ecological collapse, closed the curtain on the Mesozoic Era. The kings of the land, the masters of the rivers, and the giants of the sky were swept away in a planetary reset. Yet their story does not end in the silence of extinction. The legacy of the giants persists, a profound whisper of deep history. For the theropods, the lineage of the T-Rex, the Velociraptor, and the Therizinosaurus found a way to cheat oblivion. The small, feathered forms that survived the cataclysm evolved, diversified, and took to the skies. Every bird you hear chirping in a tree, every raptor soaring on the wind, is a direct, living descendant of the dinosaurian dynasty. The massive bone structure gave way to hollow lightness, the crushing bite to the versatile beak, the sickle claw to the grasping talon. The T-Rex's tenacity lives on in a robin's nest, the Brachiosaurus's structure in the flight mechanics of an albatross. The bones of these giants, fossilized monuments to a past kingdom, compel us to be humble, to appreciate the fleeting nature of dominance, and to recognize the incredible, stubborn resilience of life. In the vast history of this planet, we are but a blink, yet we possess the unique ability to look back, learn, and be awed by the kings who came before. Thank you for joining us on this breathtaking journey into the unyielding jungle. From our team to yours, we wish you good health and enduring strength. If you enjoyed unraveling the mysteries of these magnificent beasts and the lessons they offer for the present, please ensure you smash that subscribe button and ring the bell so you never miss another deep dive into the history of our incredible planet.